lesson today is about determining if a linear equation that you're given has a solution, either one solution, no solutions, or infinitely many solutions. So the first idea is, whenever possible, simplify an equation. If there's an x on both sides of the equation, then that needs to be simplified. If there are parentheses, they need to be eliminated using multiplication. If there is a variable, two sets of variables, x in two places, they need to be combined. So combine like terms. So you'll see in this first example is going to be a fairly complicated equation. 6x plus 12 on one side of the equation equals 2x minus 5 plus 4x plus 17. So the first thing we're going to do is look at the 2x plus 4x on the right side of the equation and gather those coefficients together. 2 plus 4x, leaving negative 5 plus 17. It's important when you're simplifying to do just one step at a time. So I'm just going to add 2 plus 4, that's 6x. I can combine negative 5 and 17 and get 12. Now this looks kind of interesting. 6x plus 12 equals 6x plus 12. We're going to create a zero pair to eliminate the 6x on the right side. And whatever you do on one side of an equation, you do the same thing on the other side. So I'm going to highlight my zero pair. 6x minus 6x is 0. I end up with a zero pair on both sides of the equation, so they can both be eliminated. So I'm going to put a question in the question column. Can a zero pair be on both sides of the equation? And the answer to that turns out to be yes. We eliminate them both. We end up with 12 equals 12. When we get a true statement, then we have what's called infinitely many solutions. No matter what the value of x is, 12 equals 12. If x equals 1, 12 still equals 12. So this equation has infinitely many solutions. Every value of x is true for this equation. Example 2, 3x plus 7 plus 7x equals 5 times parentheses 2x plus 1. So there's a lot of simplifying that we're going to do. We're going to gather the coefficients together on the left side of the equation, 3 plus 7x plus 4, and multiply 5 times 2x and 5 times 5 times 1. We're going to distribute the 5 across the parentheses. Three plus 7 is 10. We bring the 4 down, so this is simplified. 5 times 2x is 10x. 5 times 1 is 5. We're going to again create a zero pair. To create a zero pair, we're going to subtract 10x. We end up doing that on both sides of the equation, creating again 2 zero pairs. Answer that question in your notes. And I'll check for it in class. So we end up with, after creating zero pairs, the statement 4 equals 5. 4 equals 5 is not true. It's never true. So there are no solutions. There are no values of x that will make 4 equal to 5. So our first example had infinite many solutions. Our second example, there were no values of x, no solutions. Okay, example 3. Eight times the parentheses, x plus 2, minus 5 on one side, equals 6 times parentheses, x minus 1, plus 23 on the other side. So we have some work to do. We're going to distribute the 8 to 8x plus 8 times 2 minus 5. Distribute the 6 to 6x minus 6 times 1 plus 23. Eight times 2 is 16. 6 times 1 is 6. Now we're going to combine the constants. 23 minus 6 is 17. And 16 minus 5 is 11. That leaves us with 8x plus 11 equals 6x plus 17. So now we're going to create a zero pair. The 11 plus 11 minus 11 is a zero pair. That leaves us with 8x on one side of the equation plus 6 on the other side. 6x plus 6 on the other side. We now have a two-step equation. Well, not quite. We have to create one more zero pair. The reason I use negative 6x is to create the zero pair so that x is only on one side of the equation. We now have a one-step equation. There was a number and it was multiplied by 2. To undo that, we divide by 2. So x is equal to 3. This has just one solution. X equals 3 is the only value of x that makes the original equation true. So there's just one solution. You can write a conclusion in your own words about this lesson, what you know is true about this lesson. I'm going to write that all linear equations have either one solution, no solutions, or infinitely many solutions.